Okay, hi, I'm Tonie Van Dam. I'm a professor at the University of Luxembourg.
And describe your current work.
My research is sort of twofold. I do theoretical geodesy, so working with reference frames and making corrections to geodetic observations, but I also do some real science. I look at the mass changes on the Greenland ice sheet using deformation from GPS receivers that are set up around the edges of the ice sheet, and then I'm also looking at the deformation in Yellowstone to try and determine if the uplift is being caused by magma injection or whether it's just the expansion of water under the crust there.
And does your current work relate to the work you did with the TI 4100?
In one way it really does. I was involved in a few campaigns when I was a graduate student at the University of Colorado, and we did a campaign in Yellowstone, and so that ties in directly with the work I'm doing in Yellowstone now with GPS and absolute gravity. All of the GPS uses these atmospheric and environmental corrections that I work on in the other half of my research time. So,
when did you work with the TI 4100?
I worked with the instrument when I was a graduate student at the University of Colorado, and I was probably involved in these projects because I was cheap labor. My thesis advisor didn't have a focus in this area, but I wanted to travel. And so I was kind of a tag-along on a lot of these experiments. And that was in the mid-'80s. I went to Yellowstone. With that, we did a project also in Hawaii, and I was on Maui at the top of the Haleakala volcano.
What work were you doing with the TI 4100?
In Yellowstone, we were looking at the uplift. We were looking at the surface displacement in Yellowstone. And in Haleakala, it was when the instrument was still quite early, and geodetic techniques like satellite laser ranging and VLBI had been around for a lot longer. And so that experiment was about tying in this new GPS technique to the reference frames that had been developed by the techniques of SLR and VLBI.
Where did you use the instrument?
We went to Hawaii with the instrument, and then we also did an experiment in Yellowstone. This was a team project. The Yellowstone project was The Yellowstone project was Chuck Meertens and Bob Smith, and they were looking at the deformation there.
Where did you go specifically in Yellowstone? Do you remember if it was a particular area, not too close to Old Faithful? Or? No.
It was more along the line between Canyon and the lake, Yellowstone Lake. Those were my sites.
Had you ever used an instrument or technique like this before?
No. Like I said before, I'm a theoretical person. I work a lot with computers, and I am a mess when it comes to working with instrumentation. So, no, I've never worked with instruments like this ever since.
Who trained you to use the instrument?
I was trained by Chris Roken to use the instrumentation. That was a long, long time ago.
And who was Chris?
Chris was, we were both graduate students at the time. And Chris was really, really interested in the GPS data and using it to look at the water vapor in the atmosphere at the time.
What was the most difficult part of the training?
Learning how to level an antenna on a tripod. I remember so many hours trying to get the leveling right, having to go back to zero and start all over again, and then being in a panic because the satellites were going to be up any second. So I still think that was the most difficult thing about this field work at all.
And was that an example of one of the antennas behind you there?
Yes, it fit just perfectly on top of the tripod. Oh, it was terrible.
What was the most difficult part about using the instrument, the TI 4100?
Well, again, I'm not very good with instrumentation, so I was never very sure whether I did everything correctly or not. And then, because we only had short observing windows at these incredibly absurd hours of the day, you were always, despite giving yourself enough time to make sure that everything was set up, you were always in a panic to make sure that everything was working when the satellites started rising on the horizon.
What was the most exciting part about using the instrument?
Ooh, that's a tough one. I would probably say just making sure that everything was working. It was recording data when we had to start the when the GPS sessions, when the satellite sessions started. That was the most exciting part, making sure that everything was working so you didn't lose any observations at all.
What was the biggest benefit of using the instrument?
Oh, the benefits are just countless. It gave us an opportunity to look at the Earth and the Earth's displacement in a completely different way, which showed us things about plate tectonics. It was one of the techniques used to confirm the plate tectonics theory. It's telling us now about ice mass loss. It has been an evolution from those very, very early days when we only had 3 instruments. In Greenland, we have more than 65 instruments observing today. So the technology has come a long way, and it's touching science from atmospheric science, environmental science, climate change science, as well as all of the solid earth sciences.
Did you leave your mark on the instrument?
No, I would say that if the instrument could talk, it was probably relieved to have me not working with it any longer.
Not even a fingerprint?
Well, probably. Blood.
Did the instrument leave a mark on you?
Yeah, like I said, I have a few mental scars from going into the field with this instrument. We don't have the luxury. We didn't have the luxury back then that we have today, where you turn on a GPS receiver and you can see 12 satellites at any time. So we were always pressed to make the most of the available window for observing that we had. And that caused lots of stress to make sure that we got those observations.
Yeah, and at the time you didn't have like an iPhone that had a GPS device that
oh my gosh,
telling you where you were.
No.
How did you decide where you were so that you could accurately mark your location?
Well, that was pretty tough. No, we all right, so well, actually, at the time that we started using these instruments, we were making the marks that other people would use in the future. So we established sites at Platteville. The survey we did in Hawaii on Maui, that was the first time that GPS had been to those sites. So we were actually putting in the markers that other people would use in the future.
So you were doing the triangulation?
No, not really. We were just putting in brass pins so that when other people came back to measure the same spot, they knew where our antenna had been set up before.
Okay. Do you have a fond memory about the instrument to share?
Actually, fond memory I could stretch, but fond memories have to do with the people that I went into the field with. And everything we did, the extremes that we went through to get the observations. Those are very, very fond memories. I made a lot of hilarious mistakes with the instrument. I left a tripod one time. I was known for having the most ugly antenna setups of any of the field operators because I couldn't level a tripod to save my life. So yeah, those are the memories, fond or otherwise.
Is there one particular memory about the actual instrument that you...
I remember it was heavy. I remember praying to the GPS gods that it would start on time and that I could upload the software without the first time without having to start from the beginning again. Yeah, those are the things that I remember about the TI 4100. There was also a time we were doing field work in Platteville, and I was with Chris Roken at some absurd hour of the morning. And to keep the instrument going, we had to plug it into a car battery, and I switched the cables, and there was a small explosion in the back seat. Thank goodness it was just a spark. The instrument and the car survived.
How did the instrument contribute to advancing your work?
Oh, I've kind of touched on this already, but compared to the other geodetic techniques that we have today, there is no other piece of equipment that is so inexpensive, not including the satellites, of course, that is so inexpensive, so easy to install, and runs almost 100% reliably. So that means that we can, things that we could only imagine measuring, they're a reality now. We're looking at how Greenland is changing. The ice on Greenland is changing from year to year just because we can see the uplift because of these instruments.
How did the instrument benefit others and more broadly society?
The theory of plate tectonics. When I think of what this instrument did in contributing to establishing that theory, it's just incredible. I've never been so close to something that's been so important in terms of changing the way people think about the world. And there's tons of examples of experiments where GPS has contributed extensively to our understanding of the Earth and the environment.
And so how would, Joe the plumber benefit from knowing about plate tectonics?
Well, that's a hard one, but I think that with what we know about crustal displacement now, Joe would know where to buy a house that would be far away from a zone that's undergoing stress or something like that. So I would say that that's how the normal person would be affected by things like this. And of course, all of the environmental changes that we're observing, people might not realize it, but everybody's going to be affected by climate change. Everybody on this planet is going to be affected by climate change. And understanding the extent of those changes is one of the things where we all are trying to work on. And this tool has helped a lot.
Have you used more modern instruments for the same or similar work, and how have the instruments or the work changed?
Well, like any piece of technology, as time passes, it becomes lighter, it becomes faster, and it becomes smarter. And the same can be said about the GPS equipment. If you look at this piece of equipment, when we took it into the field with its box and everything, it was about 70 pounds of electronics. And now the box for a dual frequency GPS receiver is about this big. It really weighs no less than, or no more than about 10 pounds. It's fantastic.
Yeah, what is that thing on the front? It looks like a huge cell phone.
Oh, that was one of my nightmares with this instrument. You had to punch in all of the numbers. You had to punch in the satellite scenarios so that the instrument knew where to look in the sky for the satellites at the time. Now it's all done. It's all done automatically because there's so many satellites. But in the beginning, the instrument didn't know what part of the sky it should be looking in, and so we had to tell it, give it a couple of places to start looking at, to start making it search. And this is how we uploaded the software and everything else. This was how we talked to it.
So that's the keyboard.
Yeah, that's it.
Okay.
I'm sure there was some other name for it at the time. Oops.
Yeah.
I'm going to break it.
Any other comments related to the instrument and its history that you'd like to share?
I guess I'd just like to say that it was very, very fun being a graduate student when UNAVCO was established for the purpose of buying 3 of these instruments so that the scientific community could go out and do these observations that have proven so valuable to us. It was a blast to be a part of the community at that time and to be at the center of it because I was in Boulder and that's where UNAVCO started.